All right, on a rainy Saturday morning, this is a special edition tutoring video. A couple of questions I was unable to get to on a Thursday, so this will be going up a little bit late, but I did want to answer these two questions that were sent in. So one question is from our AP Calculus, and another one is from Pre-Cal. So let's first look at the AP Calculus question. So this was one of the questions from the most recent progress check that I do want to go over because it does involve using the squeeze theorem. So just like all of our theorems that we've learned thus far, the squeeze theorem is an existence theorem. So the theorem says that if we have two functions, so I'm going to say function A and B, where the following must happen. So our function that we're looking at is f of x. So first thing that needs to happen is that our function has to be between these two functions. And the following also must occur, which is the limit as x approaches our point of interest for a of x has to be the same as on the other function. So visually, and I'm going to give some color to these. So let's say A is blue, B is green. So if we were to visualize this, here's this function b of x. And again, all of these also to A and B, let me write that up here. These are continuous functions. So we have, and then we'll say here's our point A. That is of interest. And A of x we said was blue. So let's say A of x is doing something like this. So you can see that at A, they're going to have the same answer for the limit. So this f of x, which is in the middle, okay, and I'm going to label that as black, that f of x always is somewhere in the middle. So you can see that it has nowhere else to go because the other two functions kind of squeeze it so that it has to go and be that same answer. So if a and b of x, where the function are functions in between those two, and the limit as x approaches a is the same for both functions, then the limit as x approaches a of f of x is also equal to whatever these two were. So now let's go to our question. So our question says the function f is defined for all x in the interval from 4 to 6. Which of the following statements, if it's true, implies that the limit as x approaches 5 of f of x is 17? So let's go through our options. So first option is there exists a function g such that f of x is less than g of x for the values between 4 and 6, and the limit as g of x as x approaches 5 is 17. So this is no because, and again, we can always kind of visualize these. So according to this, it's saying that f of x is the lower function. So let's draw f of x. And then we have g of x, and let's say here's our point of interest, here's A. And then we have g of x, which is always above, it's greater than or equal to. So let's say that's g of x. So this example right here, okay, it matches this condition. And the limit as x approaches 5, so that a is really 5. Okay, fine, the limit is 17, but that doesn't necessarily imply that f of x has to be 17 because it's always less than or equal to. So the problem here is with one function, I cannot do the squeezing. So A is not going to be the answer, and neither is and neither is B. Because again, you see in B, it's again the same idea with the function, only now g of x would have been the lower function, but then again, f of x is just going to be able to freely go wherever it wants. So it can't be A, it can't be B. So now I look at C and D. Okay, now I see there's two functions. Okay, so now we are potentially going to be using the squeeze theorem. But the important thing is I got to surround the function of interest, which is f of x. So if I look here, there exists a function g and h where f of x is less than g of x is less than h of x. So this can't be it because f of x is not in between my two functions, which leaves me with D as the correct answer. Now let's check. Okay, f of x between these two functions. So that's the first condition that we talked about here. So that's this condition. But now I also have to check, do these two functions have the same limit answer as we approach, in this case, it's 5. And that's the second piece. The limit as x approaches 5 is equal to the limit as x approaches 5 of the other function, and they're both equal to 17. So that's creating this situation here, where that g and h are both going to have the same limit answer at 5, so that leaves my f of x nowhere else to go except for having that same limit also as x approaches 5. So that is our answer for part D. So that's Squeeze Theorem. All right, now let's go ahead and look at a question from the pre-calculus review. So your favorite type, this is the difference quotient. So we are looking to, and again, this is practicing really evaluating functions and simplifying that expression afterwards. So let's go ahead and do this. So we have, we're looking at 54. So we have our function f of x is x squared minus 3x plus 5. Okay, so f of x plus h minus f of x all over h. So first, remember, setup, then cleanup. So setup, we're going to substitute. So f of x is going to be, let's make sure I got the same type. All right, so f of x is going to be our x squared minus 3x plus 5. Remember, you are subtracting the whole function. So we talked about this in class the other day. So when I do the substitution, I wrap the whole function in parentheses because I'm going to be subtracting all of that. Now I got to figure out, well, what is f of x plus h? So off to the side, instead of writing f of x, remember the x is just a placeholder. So I'm literally writing out the function, but just not putting in x so that I can see, oh, I'm just filling in the blanks with whatever I put in here. So what is it that we're putting in? X plus h. So guess what's going to go in all those blanks? And again, when you substitute, just make this a habit to do. Whenever you substitute something, put it in parentheses. So again, you are remembering, yeah, I'm going to have to distribute. Oh yeah, I'm going to have to expand this because it's not just h squared, or it's not just, 3x plus h. It's 3 times x plus h. I'm going to have to distribute. I'm going to have to expand. So this is what I'm now going to write over here. And again, since I am substituting, I'm wrapping that whole thing in parentheses. So this is x plus h squared minus 3x plus h plus 5. And now all that over h. So this right here is our setup. So that right there is our partial credit. Do this right with the parentheses and everything. you're good to go. So this is already half of the battle. Now the next half is the cleanup. So now I'm going to start to simplify. All right, so I'll thicken this out a little bit. All right, so now I'm going to go ahead and start expanding. So remember, let me go in green over here. So remember that when we have a plus b to a power, and I know some of you might be watching this and rolling your eyes going, yeah, I know. I keep saying it because I keep seeing people make the mistake. So I'm going to keep saying it until the entire world stops making this mistake. So that means I'm going to my grave saying this over and over and over again until I see 100% on this. So when we expand, we cannot just simply distribute the power. So I'm going to have to expand this. So again, I'm going to do my little box method for expanding this. So remember, so it's x plus h times x plus h. So I'm going to fill in the terms. So x times x times h, x times h, and then h times h. So this, when we collect all the like terms in the boxes, is going to end up being x squared plus 2xh plus h squared. There's that part. Now, here I have multiplying, so it's going to be minus 3x minus 3h. You're just multiplying is by a negative 3. And then plus 5. Okay. Now in the next part, okay, minus this. So this is, so again, another distribution I'm going to have to do. So it's minus x squared plus 3x minus 5. And then don't forget, all that is divided by h. So now in this step here, what am I doing? I am expanding and multiplying, or expanding and, let's say, distributing. Okay. Now we're going to see what terms can we cancel away. So I already see moving forward, okay, the 5 and the negative 5, they're going to cancel. I see the negative 3x, positive 3x, they're going to cancel. I see a positive x squared, a negative x squared, they're going to cancel. So you see a lot of stuff is going to cancel away, which is beautiful. That's what I want. All right, so now what am I left with? We got 2xh plus h squared minus 3h. That's what we're left with, all divided by h. So now, what did we do from this step? We canceled terms. So like terms, we cancel them away. All right, so now, okay, I look. What else could I do? Well, I see everything has a term of h. So since I'm dividing by h, I can remove an h from each of those. So that's going to lead me to now writing this. So there'll be 2x plus h minus 3. So we divided by h. And that is my final answer. Nothing else to do with that. All right, so those were just the 2 questions that were sent in. Apologies for not doing this on Thursday. Things just got a little backed up, but I just wanted to make sure to get these questions answered and put out there for you guys. So again, if you found this useful, please make sure you hit a like on the video, and I will see you guys on the next tutoring video.